Lesson 10 focuses on the properties of real numbers and the properties that also we can use on algebraic expressions. So the first properties here are commutative property of addition and commutative property of multiplication. Basically what the commutative property means is that you can change the order of how you add or multiply something and it doesn't make a difference. So for example, the commutative property of addition would be if I have A plus B, it's the same thing as saying B plus A. So 3 plus 4 is the same thing as 4 plus 3. Commutative property of multiplication, same idea, but we're talking about multiplying. So A times B is the same thing as saying B times A. Again, 3 times 4 would be the same thing as saying 4 times 3. I remember it as the CO, so it stands for change order. So let's look at an example with this. So we're going to use the commutative property to simplify this algebraic expression 5 plus x plus 3. So the first thing I want to do, so let me just rewrite it, is I want to be able to combine like terms, which really means I want to be able to add the 5 and the 3. But in order to do that, you want to get them next to each other. So by the commutative property, I can rewrite 5 plus x as x plus 5. So that's by the commutative property. And that would be of addition because I added those terms. I'm just going to write of addition. And then from there, you just go ahead and you add the numbers next to each other. So 5 plus 3 gives me 8. So the reason for that is I just added 5 and 3. Okay, so that's how we can use the commutative property. The next property is called the associative property. Associative property can be, again, of addition or multiplication. And what associative property means is that the way that you group your operation is going to be different. So A plus B plus C, here we know by order of operations we would do B plus C first, but that's the same thing as if I were to add A and B first and then add C to it. So associative property means you stay the same order, but your grouping changes. So I remember that ASSO as always stays the same order. But really what you're doing is you're just changing the grouping. So change the grouping. So for multiplication, it would be A times B times C. So you'd multiply B and C first. But that's the same thing as if I decided I wanted to multiply A and B first and then multiply it by C. So let's look at an example of this. So say I have 4 plus 5 plus x. What this is saying is add 5 plus x first, but we know that we can't add 5 and x because they're not like terms. But what I can do is I can change the grouping and what I'm going to add first by associative property. So this is because of the associative property. And this would be of addition because the operation is addition here. So now I have 4 and 5 in parentheses, so it tells me add those first, so you get 9. So your final answer would be 9 plus x. So this is just because I added. So basically, you've done this before. You've kind of ignored the parentheses, or you've automatically known that you can change the order of how you're adding. So this is just kind of saying, like, here's the properties for why we can do the things that we've always done when we simplify. Let's look at one more example here. So what if I have 12 and 2/3 x? So basically, we already know that we can just multiply the 12 and 2/3, but the reason why we can do that is because of the associative property. I'm allowed to change the grouping. I'm allowed to multiply those first and then multiply them by x because of the associative property of multiplication, because the operation is multiplication. So now when we have 12 times 2/3, remember it's like thinking of 12 over 1, multiply across the top, we get 24, multiply across the bottom, we get 3. You keep your x, so the reason for this is just because I multiplied. And then if you can reduce your fraction, which in this case I can, 24 over 3 is just going to give me 8. So my final answer will be 8x. And the reason for that was I just divided. Okay, so that's for associative. Next property we have is distributive property, which you've known and you've used plenty of times. So this looks like A times the quantity B plus C is the same thing as thinking of it as multiplying A by each part in parentheses. So A times B plus A times C. Basically, you're distributing this A through to each piece, keeping the signs. It's really important that you pay attention to that middle sign there. So let's look at some different examples of this. So if I have 2 times x plus 3, you distribute that 2 through, you get 2x plus 6. You're just multiplying it through. In this case here, I have 5 times 2x minus 8. Again, you really want to pay attention to that sign in the middle there. So when I distribute this through, I'm going to have 10x first, and then 5 times negative 8, which is going to give me a negative 40. I would say probably the most common mistakes that people make with these is that they're not paying attention to that sign. So just make sure that you're careful with that. So let's look at, I'm just going to go down here. So let's look at some more examples. So I'm basically just going to continue that example 3 there. So I have 5 times 2x plus 4y. Again, distribute that 5 through. So 5 times 2x gives me 10x. 5 times 4y is going to give me 20y. So you're just paying attention to the signs. Let's look at if I have this. Negative a plus 7. Now this one you got to think of it as, even though there's not a number in front of that set of parentheses, you really want to think of it as a negative 1. So basically when I distribute that negative through, I'm going to end up changing all of the signs. So it's just going to be a negative times a gives me negative a, negative times positive 7 is going to give me negative 7. And what about if we had some fractions? So what if I had something like this, where I had a times 1 plus 1 over a. So for this one, again, you're distributing each piece. So a times 1 gives me a times 1 over a, so this is a 1, is going to be a over a. Because again, remember you're thinking of it as a over 1, multiply across the top, multiply across the bottom, and then we know we can simplify this to a plus 1, because a divided by a is just 1. And one last one. So let's look at another one with fractions. So 12 times the quantity 2/3 x plus 1/2 y. So again, you're going to distribute that 12 through. Think of 12 as 12 over 1. So that means you're multiplying across the top. And you're multiplying across the bottom. So 12 times 2 gives me 24 on top over 3 on the bottom, because 3 times 1. And plus 12 times 1 on top is going to give me 12. 1 times 2 on the bottom gives me 2. And then you're going to just divide out. 24 divided by 3 gives me 8x. Plus 12 over 2 gives me 6y. So your answer, 8x plus 6y. The last few properties here are ones that you probably don't realize that you use as often as you do. The first one is the additive identity property. So basically this means what can I add to any number to keep its identity. So the only thing that we could add to a number to keep its identity would be the number 0. So 0 is considered the additive identity because I can add 0 to any number and it's going to stay the same. When we're thinking of the multiplicative identity, we're thinking of the same kind of concept, but we're asking ourselves, what can I multiply by any number to keep its identity? So the answer to this would be 1. I can always multiply by 1 and I keep its identity. So that's called the multiplicative identity. Now the additive inverse and multiplicative inverse means how do you get back to the identities? So you have to think, well, the identity for adding is 0 and the identity for multiplying, because it's what can you multiply by a number to keep its identity, is 1. Adding, what can I add to a number to keep its identity? Well, that's 0. So if I'm trying to find the additive inverse, what this is asking is, what do I add to a number to get out the identity? Multiplication, what do I multiply by a number to get out the multiplicative identity? So the answer to both of these, adding to a number to get 0, well, you're always just going to add the opposite. So it's just going to be negative, whatever that original number is. Same idea as subtracting. Adding a negative is really subtracting that number. Multiplicative is the reciprocal. You're going to multiply by the reciprocal. The multiplicative inverse is always going to be the reciprocal of whatever you started with. So we just do 1 over. Okay. And also just kind of take note that a 0, the number 0 does not have a multiplicative inverse because you can't write a reciprocal. If you have 0, you can't write 1 over 0 because that's undefined. So that's the only one that won't have a multiplicative inverse. So then before we try some examples, let's just talk about our last two properties, one being the symmetric property. Think about what symmetry means. Symmetry means it's the same on both sides. So like a parabola, that's symmetric because if you were to fold it in half, it would match up. So the symmetric property of equality is basically the same idea where you can flip the numbers around an equal sign. So basically if A equals B, then that's the same thing as saying B equals A. It's just like we've seen examples where we say x equals 3, which is the same thing as saying 3 equals x. You've seen that. You've done it all the time. It's called the symmetric property. Symmetric property of equality is basically what it is because it's around an equal sign. And then the last one here, the transitive property. It's saying that if you have two things equal to the same thing, then they must be equal to each other. So if A equals B and B equals C, well, we have two things that are both equal to the same thing, then they must be equal to each other. So A and C are both equal to B, so that means that A and C must be equal to each other. So let's look at some examples here where we're just going to basically look at all of these algebraic equations here and just what property makes each of these statements true. So if you look at the first one, you have to first identify what happened. So looking at A, well, what happened between these terms? The x plus 5 became 5 plus x. The order changed. So this is commutative property whenever the order changes. And it's going to be the commutative property of addition because the operation is addition. Then I look at the next one. It was the parentheses changed or the grouping changed, but you want to look at the order. Did the order change as well? So 2x, so it went 2xy and then 2xy. The order didn't change, so since the order stayed the same, it's going to be associative property because the grouping changed and the operation again is addition. And it's possible to have a combination of, commutative and associative. It's doing both at the same time. But for these, it's just one property. The next one, you can see that the 6 was distributed through to get 6x plus 18. So it's the distributive property. Next one. Well, we took 2 and we canceled it out to get the additive identity. Since we got the identity, that means this is the additive inverse. The next one, we took 3, we canceled it out to get the multiplicative inverse. So this is the multiplicative, or to get the multiplicative identity. So we did the multiplicative inverse. So remember, whenever you're getting the identity, that means that you're doing the inverse because you're going back to the identity. The next one. What's different? Well, here we have 2 plus 0 in parentheses. Over on the other side of the equal sign, it's just a 2. So we added 0 to 2, which you guys just think of, okay, it's just adding. But the real reason why we can add 0 to any number and keep it the same is because of the additive identity. So yes, we're just adding, but at the same time, the reason for it is because it's the additive identity. You're keeping the identity of 2 by just adding 0 to it. Looking at G. So I know that the grouping's changing. Here I'm going to do 2 plus 3 first. On this side, it's going to be 2 plus 4. So I know it's going to be associative property, but if you look at the order, it went 2, 3, 4. This is 3, 2, 4. So this is going to be a combination. So this is going to be the associative property and commutative property. And they're all of addition. So again, you can have a combination. And then H. So here I have x plus 2 that I'm going to add first. Over here I have x plus y. So we know it's associative, but we also know that the order changed again. So this is also going to be associative and commutative property. And again, of addition. And then the last one, oh, I already gave you this example. So if 3 equals x, you change the order around the equal sign. This is called the symmetric property. It doesn't matter which way you have the x or the 3, they're the same thing, so it's symmetric. So this is a symmetric property of equality. Okay, so that's it for that properties. The next thing we're going to look at is how to actually simplify some algebraic expressions, and we'll be using all of these properties to do that.